Let's go through a few questions that are conceptual regarding our energy diagrams. So go ahead and read through this. Sorry for the background noise of my dogs. So it's telling us that this line that is jaggedy is representing not gravity per se, but potential energy. They tell us this particle has 1 joule of kinetic energy at x equals 1 meter. So since we know up to here is potential energy, if we add 1 more joule, that's our kinetic energy, we can say the total energy is 4 joules. The potential energy plus the kinetic energy has to equal 4 joules. In this question, let's see, in the region between 1 and 2, is the particle speeding up, slowing down, moving at a constant speed, or I guess we have the option to not know. Well, if we think about just in terms of under the potential energy line represents potential, above it represents kinetic. Kinetic's getting bigger. Kinetic energy is getting bigger, which means the potential energy has to get smaller. So if kinetic energy is getting bigger, this particle is speeding up. You can think of that too. If this was just some sort of track, put a marble at point 1, it's going to roll down to point 2. Let's look at another question. Go ahead and decide what you think the answer is. So this is the same graph as the last one, and they're again telling us there's 1 joule of kinetic energy when x equals 1. So the total energy is 4. The turning point always represents when the energy is all potential, meaning where the potential energy graph crosses the total energy graph. That happens at x equals 6 meters now. Now, regardless of the forces, whatever, acting on it, we would ignore the potential energy graph past 6 meters, because as any particle was traveling in the x direction, it would be slowing down because that potential energy is getting bigger. As soon as it gets to x equals 6 meters would be when its speed is instantaneously 0, and then it would head back in the opposite direction. That's why we call that the turning point, because it's turning around. It slows down, stops for a split second, and heads away, just like tossing a ball in the air. All right, one more concept question here. What do you think about this one? The correct answer is C. Now again, when we talk about equilibrium in general, whether it's stable or unstable, we mean the slope is 0. The slope of the tangent line. So we have 2 locations, x equals 1 meter and x equals 2 meters. Those 2 locations are equilibrium points. Everywhere else, in what I can see of the graph, everywhere else has a slope that's not 0. Now for me, I remember it. Unstable, I think about putting the ball at a very top of a hill. I know if it gets nudged ever, even just the tiniest bit, it's going to roll down the hill one way or the other, and not come back. That's unstable. Equilibrium means being in the bottom of a bowl or a dip, a valley. Even if this ball gets nudged to the right or left, it's going to come back to equilibrium. 2 is the one that looks like it's the bottom of a bowl or valley. It's a really weirdly shaped since we have the sharp angles. But that's why x equals 2 meters is the stable equilibrium. X equals 1 meter would be considered unstable.